Before starting today's lesson, make sure you get your homework notebook and a pencil. That way, after I give you a problem, you can pause the video and work the problem out yourself before watching the solution. In today's lesson, we're going to continue using the general procedure to solve word problems. Let's start with a pretty easy problem. Say you and a friend went out for lunch and spent a total of $30. If your friend's lunch cost $20 more than yours, how much was your lunch? When you see a problem like this, your intuition will tell you it's 10 bucks. It just pops into your head. You don't need algebra. You don't need a general procedure. It's just right there. There's just one problem. $10 is the wrong answer. Now when people hear that, their next strategy is they start guessing. Maybe it's this, maybe it's that. They plug their answers in, see if it works. That's pretty inefficient. The general procedure, on the other hand, is an efficient way to solve problems when intuition fails. It may not seem like that right now, but with practice, you get pretty fast at it. We've worked on all the steps except for step 3. So let's start by practicing step 3, and then we'll go on to use all the steps to solve a number of problems. Step 3 has us build an English equation, and I'll do the first one and then you can try a few others. In this case, I have a washer and dryer that costs $1,000, and the dryer is $400 less than the washer, and I'm supposed to find the price of the washer. Now we're not going to solve the problem yet. Instead, we're just going to set up the English equation. The English equation is often based on totals today. And so on the one hand, I know that there's the total cost of the washer and dryer. On the other hand, that total cost has two parts. It's the sum of the cost of the washer and the cost of the dryer. This is what I mean by the English equation. Try to build an English equation for this problem. In this case, I have a total distance, and it's the sum of two pieces. There's a distance that the car travels and a distance that the bus travels. Here's another one. This problem has three parts. I know that the original amount of money is the money they've spent on rides, plus the money they've spent on food, plus the $40 they leave the fare with. And here's one more using geometry. In this case, the sum of the measures of the angles is built from three parts. There's the measure of the small angle, the middle angle, and the large angle. And if I add those all up, I have to have the sum of the measure of all the angles. Now that you've practiced with the English equation, let's practice solving problems from beginning to end. Before we start though, I want to make a really important point. Experts spend most of their time on steps 1 through 3 of the general procedure. Novices spend their time on step 4. Please practice thinking like an expert and spend your time on steps 1, 2, and 3. Don't read the problem and just try to write down the equation. One other thing, don't try to do the problems using just arithmetic. I'm happy that you can sometimes get an answer. Unfortunately, this is a course about algebra, so you have to learn to use algebra to solve these types of problems. I'll run through the first one and then you can practice on some. In this problem, I have a high school play with adult tickets and child tickets. I know I sold a total of 276 tickets, and I'm supposed to find how much of each type of ticket were sold. Starting with step 1, I know my items are adult tickets and child tickets. I know there's a total of 276 tickets, and I know I'm trying to find how many of each type of ticket were sold. I don't know the number of child tickets or adult tickets, so I'm going to let X represent how many child tickets were sold. Now I do know, though, that the adult tickets were 40 more than the number of child tickets, and so I can say that the adult tickets will be x plus 40. Next, I write an English equation, and in this case, the total tickets will be the sum of the child and adult tickets. Once I've got my English equation and I've done steps 1 and 2, from here on, it's just a matter of substituting and solving. I know the total number of tickets is 276. I know the number of adult tickets is x plus 40 because I did that work above. And I know the number of child tickets is x. I just fill that in. Solve the algebraic equation by combining like terms and subtracting 40 and dividing by 2. And I find that the number of child tickets is 118. I know that that's the child tickets because up above I said the child tickets would be x. Well, if there's 118 child tickets, there has to be 158 adult tickets because there's 40 more. Now together, the child and adult tickets should add up to 276. And when I add up, the check is 276. So I'm comfortable with my answer. Why don't you try this one? Well, here's our problem we started with, and we know it's not $10. We have our lunch, our friend's lunch. We know the total's 30, and we're supposed to find the cost of each. If I say that the cost of my lunch is X, then we're told that my friend's lunch is $20 more, so that would be X plus 20. And now the English equation will be that the total lunch is the sum of my lunch and my friend's lunch. I can now just start to substitute. The total cost is 30, my lunch is X, my friend's lunch is X plus 20. Once we've translated to algebra, it's pretty easy to solve the algebra because of the work you've previously done with solving equations. We find then that the real cost of my lunch was $5. My friend's lunch was $20 more, so their lunch cost $25. And together, it's supposed to be a cost of $30, and it is. Try this one. Practicing step 1, we know that our items are students and professors, that there was 870 people total, and that we're supposed to find the number of students and the number of professors. We don't know either, so let's call the number of professors x, and then the number of students will be twice as much, or 2x. For the English equation, we know that the total people on campus will be the sum of the students and professors, and so now we can just translate. The total people is 870, the students are 2x, and the professors are x. We can solve this algebraic equation and find that the number of professors, that was our x, is 290. The number of students then has to be twice as much, or 580. And when I add up the professors and students, I should get 870, and I do. Here's a problem that involves a triangle. Well, the items are the measure of the three angles, and we know the total measure is 180 degrees, and we're supposed to find the measure of each of the three angles. For something like this, I like drawing a picture. I know that the larger angle is going to be x, and I have two of those that are the same. And then the small angle is going to be 42 degrees smaller. The English equation would be that the total measure of all the angles will be the measure of the two large angles added to the measure of the small angle. Now we translate, solve, and answer the question. The measure of the two large angles will be 74 degrees each, and the smaller angle, which is 42 degrees less, would be 32 degrees. If I add up the measure of all three angles, 74 plus 74 plus 32, I should get 180, and I do. Here's a common type of word problem. In this problem, our two items are the larger and smaller integer. We know the sum is 113, and we're supposed to find the value of our two integers. I'm going to call the smallest integer x, and I don't know the large integer either, but I do know that since the integers are consecutive, that whatever the smaller integer is, if I add 1 to that, I'll get the larger integer. It's the next one in line. I've been told that if I sum up my two integers, I'll get 113. So I just translate into algebra, solve the algebra, and answer the question. When I sum the integers up, I should get 113, and I do. Here's a problem with 3 parts. I'll give you a little hint with these. Whichever item is talked about the most, that's your best choice for your variable. Well, we have 3 items. The first, second, and third job. We know the total that's earned is $2,200, and we're supposed to find the amount made at each job. Now, I like drawing pictures for these things, so I'm going to have a picture for the first and second and third job. We know the total is $2,200. If the first job is X, we're told that the second job earns us twice as much, so that would be 2X. And then that the third job earns 300 less, so that would be X minus 300. It's 300 less than the first job, and the first job was, well, that's our variable X. The English equation would be that the total that we earned will be the total from the first, second, and third job added together. And now we translate. The total earned is 2,200. The first job is X. The second job is twice as much, or 2X. And the third job is 300 less. We can now solve our algebraic equation and find that the first job paid $625. The second job, which was twice as much, would be 2 times $625, and the third job, which was 300 less, would be $300 subtracted from $625. If we add up our 3 amounts, we should get our 2,200, and we do. Let's finish with one more 3-item problem. Well, my items are the 3 types of gas. There were 14,400 gallons total, and I'm supposed to find how many gallons of each type of gas were sold. Now again, notice which one is talked about the most, which are the items, and it's the amount of premium, the gallons of premium, so that's going to be my variable. I'm going to draw a picture again. Now the premium is X. We're told the gallons of super is 2/3 as much, so that'll be 2/3 X. And the gallons of regular will be 800 more, so that would be X plus 800. The total gallons we sold will be the gallons of regular and super and premium added together. Now we translate and solve and find that the gallons of premium is 5,100. 2/3 of that will be the gallons of super, and 800 more will be the gallons of regular. And if we add up all the gallons of gasoline, we should get 14,400, and we do. Well, I'm hoping that this discussion of how to solve word problems has helped make word problems a little more comfortable. If you can think of ways to help make these videos more useful, you can always drop me an email at scott.storla@minneapolis.edu. Thanks.